Yes.
Cool,
Thanks,
cool. Yep.
Awesome. Well, hi, everyone. Thank you for attending our last workshop of the day with Alvin, who's presenting an introduction to Kubernetes. This workshop will be awesome to help you discover core Kubernetes concepts as you learn more about different resource types, while also being able to research more about modern infrastructure problems that Kubernetes and containers in general solve. I'll hand it off to you, Alvin. Thank you.
All right, thank you. So hey everyone, good afternoon, evening to you all here. We don't have a lot of timers, so I'm going to try to dig right into it here. Now today's session, we're going to talk about Kubernetes. Now you've probably heard this a lot. You've probably heard cloud native development a lot, or you're going to continue to hear it a lot as you enter and start your careers, or some of you are already there. You've probably heard it already. It's a really cool tool, and it's not just a tool, it's a tool set, it's an architecture. There's a lot to it, a lot to unravel here. So today's focus, we're gonna try to just go, what is it, like a mile wide and an inch deep. We're gonna try to touch as much as we can, as quickly as we can here. It's gonna contain a bit of theory, it's gonna contain a bit of practical, and you're always free to follow along here. Now I am gonna share this here with you guys in chat. This is just a link to today's workshop. You can find the material, which is the slide deck I'm sharing with you here today. On this page, you can also find a cluster credential, which we're going to get into here shortly, how you can use this to connect to an existing Kubernetes cluster that I've spun up for today's workshop. All right. Cool. So without further ado, let's go ahead and get right into it here. So before we even start to breach the concept of what Kubernetes is, we need to talk about containers, because at the end of the day, that's all it is. Now, containers, they're units of code. They're executable units of code. And what we do with these containers is we take an application, we're basically packaging it up with a whole bunch of dependencies, dependencies that our application needs, that the file system would need to run our application. We're wrapping this all tightly together, and we're producing this one little binary package here that we can run somewhere. Now, that's what we're going to talk about here in our first segment. We later are going to talk about Kubernetes. This is, we're going to get into, I guess, in about 10 minutes, so 5-10 minutes, where we'll get into the meat and gravy of a whole bunch of really cool stuff, starting off with the control plane, along with some different API resources in Kubernetes. And then we'll, if we have time, we'll close off with a bit of tuning and some Q&A. Now, yeah, let's continue this discussion here. What are containers? Now, containers, at the end of the day, they're just isolated process sandboxes. So whenever somebody tells you or asks you what a container is, that's in a nutshell what it is. A process is an application, right? It's anything you run. So a web browser, this PowerPoint presentation, Notepad, they're all examples of applications which have a process. They have a process which runs on your computer. And in a traditional computer and a traditional multi-user operating system, so something like OS X on Mac or Windows, Microsoft Windows, or think of any Unix/Linux system here, Ubuntu, CentOS. They all execute processes in two primary things. First of all, in the same namespace. So those resources that processes share, they're going to be all within that same namespace, and all processes within that multi-user operating system are usually executed in the same namespace. They're also executed in the same process C group, which is just how you restrict resource consumption. So say if you're running a dozen Chrome tabs, right, in one instance of Chrome and a dozen Chrome tabs in another instance of Chrome, those are all going to be sharing resources that are a part of the same C group, because at the end of the day, they're all going to run the same namespace in C group. Now, here's where it differs, right? That's a traditional system. But when it gets down to containers, well, what are we isolating exactly, right? Because we know we're containing this application. We're going to be packaging this all together and we're going to be isolating it. So how are we going to be isolating it? And this is the exact way that we're going to do it. We're going to run each of our applications, each of our processes in this case, in its own namespace and its own secret. So you can only see the resources for that application, or that process can only see the resources that it has access to, and it can only be allowed to execute and use the resources that it has been given. So I have two examples here of two different kinds of ways to execute processes. We have a typical Unix or Linux file system here, where you have a single file system, a single process namespace, a single C group, and then all your processes just run underneath there, right? One after another, you just run them. And then we have contained processes. So these are containers, right? We have a namespace per process and a C group per process. The last thing about containers here that you should know is that they are also lifecycle coupled. So in the case of our right example here, right, where we have a process, we have C group, we have a namespace, everything from this red rectangle downwards, like going inwards towards the process, all of that only exists for the life cycle of that process. So while that application runs, all of that exists. The moment that application is terminated or it's killed, that's all gone. It's all deleted, garbage collected, cleaned up, however you'd want to say this. But it doesn't exist after the life of the process ends. Now, when we want to create containers, right, because we know what a container is. A container is just a packaging of an application. Well, how do we create them, right? How do we get these applications into these containers? Because it's not always it's not always something we think about on a day-to-day basis if we're looking at a typical container. But there's lots of ways, right? There's lots of ways, and a really common example that you will see that is used in the industry today is with Dockerfile. Now, Dockerfile is just a way to programmatically build out a container. I've given an example here of how we can build out this simple container. We start off with a base image. All containers start off with a base image, right? Something that we base everything off of, some base file system, base dependencies. In this case, we're just using Ubuntu. Then we go ahead and we install some prerequisites, right? Because whatever application we're about to put in this container may require it. Say if you're writing a really cool Python application, it's going to need Python. So we're going to go ahead and install those two. Then we're going to go ahead and change our working directory because it preps us for the next step where we copy our application into this container. Now, this would be executed on some kind of automation server. If you are to release an application to production or in a company, but if you're executing on your local machine, it would just go ahead and copy your application from wherever it is you're executing or building this Docker file into this image, into that same working directory, that /app within that container. Now, once we have it in there, it's time for us to run it. And there are two things that we're doing here. The first thing is we're going to set up Yarn in the case of this application that needs it. So we're going to prepare that. And then we're going to actually execute the process. We're going to start the process that's going to give life to this container. All right, that's what's happening here on line 7. And it's a close it off because this is going to be a networked application. We're just going to say, okay, we're going to expose this port. This container is going to be expecting traffic on port 88. That's what we're saying there on line 8. Now, Docker files are really simple to read. And it's really cool because you can look at a Docker file and you could see that at the end of the day, images are indeed like onions. They're just layers. They're layers of dependency, layers of code that we're stacking upon each other to create this container. At the end of the day, this from Ubuntu, right? Ubuntu is just another distribution of Unix. So it is an image off of something else. And then you can go down even further and further, and you'll get to some images that you'll see in the industry that are pretty complex. They have a pretty large set of layers here that they're built upon before you can get to the application tier. but yeah, it's really nice to see them built like this because first of all, it reduces your work, right? Imagine having to take a look at this and saying, all right, well, I'm going to need to include every single dependency under the sun instead of in this case, well, this Python, right? They reduce a lot of that work for us. And furthermore, building them up like layers helps us with something else. It helps us when we're looking at this image from maybe a security perspective, right? We want to say, okay, if some portion of this image, if some layer of this image gets compromised or something is wrong with this image, what do we do, right? How do we swap this out? How do we remove this, replace it with something? If you're running this application on a traditional system, right? Like say you're running it on your computer, you're just running a Python application on your computer. It might be a bit tricky, right? To find out that dependency to that piece of code that has been exploited or that has like some kind of security vulnerability to. And you might not always know, well, what are the implications if we update it or what are the implications if we remove it? Well, it is super easy in the case of a container here to just update, remove it, build a container, and run it again and see what happens. All right. So yeah, that's the main thing about containers, right? We have containers. We have container when they are running, we call them container runtimes, and then we have container images, which is evidently what we're seeing here, codified. We take this declarative code here for programmatically building a container image, and you build out a image, which is again just a single file, executable code. Now, yeah, I've covered some of these already here just now about the about how it makes it easy for us to automate image building. Some of the cool things that container images also help us do, right, for packaging. If we want to host, develop, or share this application. Say I have another developer that's a part of my team and I want to give it to them so they can run on their computer. Well, it's super easy. I can just give them that image file, right? They can just run it immediately. There's no work that they have to do to say, oh, well, what if I'm running the wrong version of Python, right? Or an outdated version of Python. Well, it's all packaged in my image, so you don't worry about it, all right? And of course, a really big thing here, the whole fundamental concept of containers is they provide isolation and pretty lightweight isolation. So now we get into Kubernetes, right? That was a pretty big lead up here to the topic of today, Kubernetes. And where does it fit, right? Where does it fit into this whole life cycle of things? Kubernetes is just an orchestrator. So when we're running containers, right, we can run one container on a machine. We could run two. We could run many. We can run as many as we want. But you know, the more you run, the harder it gets to manage them. The harder it is to manage your containers, to manage the life cycle of your containers, to keep them up, so on and so forth. So Kubernetes does a really good job at that. That's its whole purpose. It orchestrates our container management. It automates the deployment, scaling, and of course, management of our containerized applications. Now it introduces a whole fleet of really cool features that it also does, such as automating rollouts for us. This is when we're going to cover this in a bit, actually, but when we want to scale out our application. Service discovery and load balancing, if we want to load balance our application. Storage orchestration, secret and configuration management, which is always fun. And there's a whole bunch of other really cool things there that I'll share as part of the resources at the end here. We won't have too much time to go into all of them, but we'll try to touch a few of these here today. Now, the first thing I guess that we should start with, right, if we're talking about Kubernetes, is to break it apart, right? We want to break apart the main Kubernetes construct here of a control plane and show you guys that it's not as scary as a lot of people think it is. Because at the end of the day, Kubernetes is an application, right? Like anything else. So what does that application include? Well, it includes several components. Now, the biggest construct here, right, of Kubernetes is it runs within this construct we call a cluster. A cluster is just a group of nodes. Nodes can be physical machines. Think your computer that's sitting in front of you. Think a virtual machine. Think even a container. A node can be a container. It's just some kind of compute. something with CPU, with RAM, probably with storage. And then we have our different Kubernetes components here in the control plane. You'll see that we have in the middle of everything, we have there an API. That is the main Kubernetes API. That is how you interact with all the components in the Kubernetes stack. So all the different Kubernetes resources, even your own application that's running on top of Kubernetes, that is how we'll access it through this Kubernetes API. Around it, you will see some other dependencies, such as the Kubernetes scheduler, which is in charge of intelligently scheduling our pods onto these nodes. Right, in this diagram, I have 6 nodes. So if I'm going to run my application, where's it going to run? Well, Kubernetes scheduler is going to help us do that, help us determine. We also have a kube controller manager. So that's this one right over here, CCM. And this guy helps us as a control loop. It basically is going to try to enforce our cluster state. So there's a lot of moving parts to Kubernetes, right? And you want to make sure they're all healthy, almost like a human body. Each of these have their own checks and balances. And this kube controller manager helps enforce those checks and balances to make sure our cluster is in that healthy state. If something isn't healthy, it'll try to restart it. If something is old or stale, it will try to delete it. If something isn't running, it will try to start it for us. We also have a cloud controller manager. And this one is to link clusters to a cloud provider API. So think if you're creating a Kubernetes cluster and it's in Amazon or it's in Azure, they'll probably have a lot of really cool features that your cluster can take advantage of as part of their platform. So this will help you go ahead and link into that platform and interact with the different components of that cloud provider. We also have etcd or etcd. It is a very simple key value store. It's a cluster data store. So Kubernetes needs to store its configuration data like anything else, and that's where it stores it. We then have these two over here, kubelet and kproxy, that are not part of the control plane natively, but instead they run on every single node in your cluster. Kubelet is just an agent. It's an agent that runs on every single node in our cluster. It ensures containers are running, and it communicates the status of those containers and the node itself back to the API. Then we also have kproxy, which is, again, another agent, but it maintains some of the network rules that we need to facilitate connectivity between our pods. So our pods, they talk to each other, they talk to services inside of the cluster, outside of the cluster. Kproxy just helps us maintain the network rules that facilitate them. On the next page here, I just have a quick legend for these different icons. So when you are reviewing this, you can take a look at this page or just see what they are. Now, today, I think the most practical way for us to go over this and to go over Kubernetes in general is to just go over it with an example. And that's what we're going to do here. So I have a WordPress site. It's deployed. You can see it running in a web browser here on the right-hand side. It's also the same website that you will be getting these workshop resources from. It is running in Kubernetes, and we're going to explore some of the different components that make up this cloud-native WordPress architecture, this architecture for WordPress that runs in Kubernetes. And we'll see here at the bottom that there is a very scary diagram, but it's not that scary. There are a lot of terms and a lot of components in that diagram that look very unfamiliar, but we're going to cover each of them right now. So what I suggest you do is you keep this open, maybe take a screenshot, or if you have the document open on your side, great. Keep that over there and just keep this on the side and go through it as we cover the different components here. In addition, I have a credential, which is just a small file that helps you connect over to this cluster, which you can download from the same web page that I've shared in chat, along with the workshop content. So if you haven't downloaded that credential file, go ahead now, and it'll help you play around with this cluster either today or at the end of our workshop whenever you want to hear. Now, the first thing we're going to talk about is pods. A pod is perhaps one of the simplest construct for our workflow, for our application. It's one of the smallest constructs too. It's perhaps one of the smallest units of compute that we can have here that can create one or more containers. And it shares compute in the case of CPU, it shares networking, and it shares storage. Now, this pod, it executes somewhere, right? It contains containers, so we know that it needs to run somewhere, right? Our application, our cool Python application that we created needs to run on something. So it goes ahead and it schedules this pod on a node. So a pod just contains one or more containers, and Kubernetes schedules this pod on a node. Now, when this pod is scheduled on a node, it'll run to completion. And in most cases, like if we're hosting a web server, well, it doesn't really complete, so it's just going to run indefinitely, right? We just want it to complete, to completely remain up and running, never out. So it's going to run indefinitely. There are some cases where you do want an application or service to terminate. Maybe you're creating a job, right? Maybe it's a very simple job that copies a file from one location to another. So when it's done, right? And in that case, well, sure, the life of it is limited. Now, pods are mostly mutable. And what I mean by mutable is a pod resource in Kubernetes, we can change a lot of things about it. So we can change the kind of containers that are inside of it. We can change the version of the images that are used in those containers. We can change the resources. Like if I want my application to have more CPU, I can increase that. But things that we cannot change would be things like our pod name. Some of the metadata about our pod, like our pod name and the Kubernetes namespace that it runs in. Now, all pods, it can run independently. They don't need anything special, any other special construct to run. You can just create a pod raw and just run it on Kubernetes. But when you're running an application where you want multiple instances, so you'll see in our example here today, we have WordPress. When we want to run multiple instances of WordPress, we might want to use a controller, right? Because it's gonna help manage things for us. We're already using Kubernetes to help orchestrate our containers. Let's take full advantage of it and use some kind of controller to manage all the different pods we're going to have for WordPress. And a really common example of a controller I have here as well here, and that would be a deployment. A deployment is a controller. It manages the life of multiple pods, one or more pods. And how it does so is it describes a desired state. So it tells Kubernetes, okay, I want 3 WordPresses running. WordPresses, that's such a weird thing to say. I want 3 WordPress instances running. And these WordPress instances, they have to be up, of course, right? They all need to be using resources. They all need to maybe have access to this kind of storage. And Kubernetes is going to do that. Kubernetes will create those pods for us. It'll make sure all of those states are true. And all those checks and balances are complete to run our application. Now, a deployment, again, as I said, it's a controller. So it describes the state, right, that we want all of our pods to go into. But when we have one or more pods, it's in another term, it's also known as a set. Now, a deployment in and of itself is not a set. It actually abstracts a set. So it sits on top of a set. So if you're thinking of it like a sandwich, right, we have our deployment, which describes the desired state for our pods, the set, which represents one or more pods, and then our pod itself. So what is an example of a set here? And I've given us one here in the case of a stateful set. There are other kinds of sets, there's replica sets and so on and so forth. But just for today here, I'll give an example of a stateful set and we'll see one as well. A stateful set in our case maintains a consistent identity for our pods and our pod resources. Because at the end of the day, right, a pod in a Kubernetes cluster, its lifetime is not guaranteed, right? It's pretty ephemeral. A pod can be created on the whim, it can be destroyed on the fly. The life of a pod is never really guaranteed. Some may say it's kind of sad. It's kind of sad, the life of a pod, but it is what it is, right? It is what it is. They do their job. So they don't really have an identity, right, in and of themselves, a typical standard pod. But sometimes we do. Sometimes we want them to have an identity. Sometimes we want them to be unique, and we want them to be consistent, even amongst restarts. So meaning even if our pod is terminated and it starts again, maybe even if the node that is running on, the VM or whatever physical host that it's running on dies, maybe it gets thrown around in a hurricane and now the pod is forced to come up on a different computer, right? We want it to be consistent there too. A stateful set will help enforce that. And we'll get into here right now what these three look like in a cluster. So today, to get into our little demo environment here, I just have a cluster that I've deployed locally, and I'm going to be using a command line utility called kubectl. I'll share a download link for this in chat. Again, it's purely optional. If you want to follow along with today's session, you can download this and run it locally. You will need that little config file that I've shared. Again, on the same page that I've put into chat. And here we go. I'll drop this in here if anybody's interested in installing kubectl. And then, yeah, and now if we're going to do any operation on the cluster, and this is just for you guys as you're following along, any operation that you're going to be doing on the cluster, you would just prefix it, or I guess in this case, postfix it with kubeconfig and then the name of the file. And this can be a path to here. So this can be a system path to wherever you've downloaded a file to. All right. So let's go ahead here and let's take a look at some pods. So here we have the pods that are running the site that you've accessed these resources from. We have our database for WordPress. It's on MariaDB. We have Memcache. We also have our WordPress application itself, which is running 2 pods right now. We have 2 pods. This is great because if one of these pods die, the website isn't completely down. The traffic will get load balanced over to the other one, and we'll get into a little bit how that works here. And in the essence of time, I'm not going to describe our deployment in stateful sets. I will just describe this pod for now. So we'll take a look at this pod here. So this pod has a whole bunch of spec information, has a description, for what the pod is, the namespace it belongs to, as well as a bunch of cool labels here to describe, well, where is this pod and what it is. Some of the more important stuff that you need to pay attention to here is the containers. The containers, of course, are going to tell us, well, what is the application running in a pod? Because a pod is just multiple containers. In this case, we have a container for WordPress. This is the image of WordPress that we're using. We also have some more info here for ports, the kind of ports, network ports that we're going to need to expose for WordPress, and as well as some other stuff about state, and so on and so forth here. Now, for those that don't know WordPress, by the way, maybe I should have introduced it a bit, but it's a blogging / CMS tool. You can host a website with it. That's the website that I've shared in chat. So as with any site, right, as with any or most applications here, it needs to have some kind of storage, some kind of persistent storage. In the case of this site here, right, it needs to both store the text that you see on it. It needs to store all of the images that it has, the files. There's some really cool HTML and CSS that renders all of that. So that needs to sit somewhere too, right? All of that we identify in Kubernetes with what's called persistent volumes. A persistent volume in Kubernetes is a unit of storage. So this unit of storage can be anything, right? It can be a hard disk drive. It can be a USB that's plugged into a computer. It could be an SD card. It could be a network share, some kind of network volume that exists on a network that that host is. There is no limit to what a volume can really be. Now, these volumes, they can be provisioned in one of two ways. They can be static, in which you manually go through and you create that volume yourself. So I, as like a cluster administrator, I might want to say, okay, I'm going to create a volume to represent this hard drive that I have, right? That I have plugged into this machine, and I want to be able to access it in the cluster, so I'll create that volume. Another type is a dynamic type, in which it's going to be created automatically as dictated by something called a storage class. And a storage class is just a fancy, another fancy object here, another fancy Kubernetes API object. We won't cover it today, unfortunately. Don't have the time for it. But it's just an object that's going to describe what that storage is and where it is, what type is, where it comes from. It's mostly seen this dynamic type with a cloud provider. So say we create a application in some kind of cluster that is maybe in Azure or in Amazon. And when we create this cluster, we create this application, it needs access to some kind of volume. And we're going to create a dynamic volume. In that provider, they'll probably create a new disk. They'll create a whole new storage device or medium out of nowhere, out of thin air, and attach it to whatever host that this pod runs on. That's what's great about dynamic when you're using a cloud provider, is all of that stuff you don't even need to think about, right? And then, of course, when we have our storage, right? Whatever ways you decide to get your storage, it's up to you, right? Whether it's with a cloud provider, whether it's with a USB drive plugged into your host, you have your storage at this point. How do we bind this storage, right? How do we bind this storage to our application, to our pod? And that is with what's called a persistent volume claim. A persistent volume claim is a request. Our application, our pod, is going to make a request for a unit of storage. Now, this request, it's really simple. It's just going to tell Kubernetes, hey, I see you have this kind of storage, and I want to use it. So Kubernetes is going to go through whatever it needs to do to both mount that storage, make it accessible on the node, which is, again, just another VM or physical host that that pod is running on. It's going to try to make that available on that node. And then it's going to mount it into our pod. Now, when it's going to mount it, there are different kinds of mounts that it can do. We call them access modes. There's different kind of binding modes that we can do here. We have a read-write once mode, in which we go ahead and we can mount the storage, right? Maybe it's a USB drive. We mount the storage into this pod. But when we mount it, it can only be accessed by the node that's running. So the node that has this pod, where that storage is mounted, only pods in that node can access that storage. That is really useful. Say if you have a hard disk drive and you want it to be accessed on this specific node only because, well, that's the only physical machine that that hard disk is plugged into, then it makes sense, right, that we want to use read-write once. And then we have read-only many. Read-only many is great because we can mount it by many nodes at a time in read-only. And this is, as you can probably guess, only really good for storage that is widely accessible, not specific to a particular node. So think something like a network storage, some machine that exposes a network share that many hosts can access. This is where we would use read-only many here. And then read-write many, which is the same thing, except it's not read-only. Applications can write to that storage as well. Now in the case right here of our WordPress installation, let's go ahead and take a look at the volumes that we have. Let's put the full thing here. So at the top here, we have two volumes. we have a volume for our database, a volume for WordPress itself. This is the WordPress application, so the PHP application for WordPress. And then below that, we have the claims that are made by pods to this application. So if we go ahead here, we can describe any one of these. Let's go ahead and describe this. Maybe the WordPress one might be more fun. Let's describe this volume. So when we take a look at this volume here, we'll see a lot of info about the volume. We're going to see some stuff such as, well, what are the access modes? We'll see the capacity of it, which is going to be the size here. And we can see the source, in this case, of where it's coming from. Now, this volume just so happens to be a networked volume, networked storage. In this case, it is a folder that sits on some server that is shared using NFS protocol here for other hosts in the same network to access. So that's what this is. We have this folder here that is mounted in our application pods represented by this persistent volume and requested by a persistent volume claim. Now the claim we can also take a look at, right? Let's take a look at our claim. And you'll see that our claim contains info again, just like before with the persistent volume, it contains the capacity, but it also has binding info. So it has info that shows us what is using. And in this case, it's going to be the two WordPress pods that we described earlier. Those two pods are what's using this piece of storage right. All right. So persistent volumes and persistent volume claims are really useful in the long run here, because when you are running an application, you shouldn't need to worry about what is the storage, the underlying storage for this application. And Kubernetes abstracts that away. So some cluster operator, some DevOps engineer is going to go ahead, create all that storage up for you. So you don't have to worry about it. All you need to worry about is you, the person, the engineer, maybe it's creating or going to be managing WordPress, is I need access to this volume. I need access to this volume. And the engineer or DevOps engineer that's going to be creating these persistent volumes and persistent volume claims will do so that your application can access it. Now we get into config maps here, config maps and secrets. Now, WordPress is not the only application to have secrets, and there's a lot of applications like this where they have some kind of secret or credential or some kind of sensitive info that they need stored. And at the same time, maybe they don't. Maybe it's not so secretive. Maybe it's just configuration data. Maybe it's just config data, like, maybe a host that it needs to access. Maybe it's just like a time zone. Something simple, right? These are all examples of different kinds of key value data that your application may need access to. And Kubernetes has these key value constructs that you can utilize for storing and accessing that data. Starting off here with the config map. A config map is just a non-confidential key value store, like a dictionary, right? You have a key and it has an associated value, just like how you take a standard, an English dictionary, or whatever your favorite language is, you take a look at that dictionary. It'll have different keys, in this case, words. And beside each word, it's going to have a description, right? What that word is, that's going to be the value. They're all unique, right? We'll have different descriptions for one word, but there'll always be one word, right, for one or more descriptions. We also have, for a config map, how it can be consumed here. So a config map, you can consume the entries that we have in that dictionary in three main formats. We can consume it as a command line argument when we're running our container. We can consume it as a configuration flat file. So more commonly, right, when you have a application that you're running, maybe it reads its configuration from a file. Config map can help us prepare that file, can help us store it write it out to a volume where that application can access it. And then last but not least, environment variables. Maybe your application reads from the system environment and it needs some kind of data from there, in which case a config map can help you load that data in for your application. Now, just two or maybe three quick caveats there, or things you need to think about, right, when you're creating a config map. It is a key value store. So the keys and values, they have to be UTF-8 strings. Well, the key, there's a bit more restriction on that, but the value, though, it's got to be UTF-8 strings if it's just standard data. If it is binary data, so this can be something like a certificate, then it needs to be base64 encoded. And last but not least, config maps need to be less than 1 megabyte in size. Now, why the size restriction? That is probably because config maps are stored and managed by the Kubernetes control plane here, the Kubernetes API. So it's stored in the same unit of storage that is used by Kubernetes. It's not in its own little dedicated storage pool. So it's sharing that service or sharing that storage with a lot more important components running in your cluster. So there's a reason it's limited in size. And of course, the big boon, right? The big benefit here of using config maps is now we get to decouple all of this application configuration from our containers. We no longer need for our WordPress to care about what is going to be the default password it needs when it starts up. We don't need it to care about, well, what are the different, maybe what are the different plugins or what are the different PHP configuration items it needs to initialize PHP within that container. It doesn't need to care about all of that anymore. All it needs to know is that it's going to get that data. It's going to get that data from somewhere, whether it's a command line argument, whether it's a configuration flat file, whether it's an environment variable, and a config map is going to help populate that information and give it to that running container as it needs it. Now I also have on the same slide here is secrets. To talk about those a bit as well here, because a secret is pretty much the same as a config map. Like in the background, I'm pretty sure they're the same thing. They're again key value stores. But a secret is dedicated for sensitive information. So this is sensitive or confidential information that shouldn't be available in plain text. You don't want people to read it in plain text. Think like passwords, right? Database passwords, maybe private keys or certificate keys. It's sensitive data, right? There are, again, some caveats there, some things you got to think about. Similar to config maps, they also have that 1 meg size restriction. But the data by default is going to be base64 encoded. So by default, any secret that you're going to create, if you're using a data property, it's going to be base64 encoded. Otherwise, you can just define, plain text UTF-8 strings with a string data property here. Otherwise, if you're looking at a secret, it's just like a config map, nothing fancier than that. So let's go ahead here. We'll take a look at a config map. We could take a look at a config map because the secret is basically going to be the same as a config map, so there isn't much to see there. Let's use this terminal down here. So we have two config maps here for WordPress. We have one that's going to contain some configuration data for MariaDB, and we have some for WordPress PHP. So let's go ahead here. We'll describe this config map. And this is all it is. Super simple. It just contains some simple data here. These are PHP instructions for when PHP engine is starting. This helps us determine, well, in the case of WordPress, you see some stuff here like max file size that we can upload. These are all configuration parameters that are going to get pulled into the application container when it's going to start and be used to initialize PHP. Last but not least here in our little journey here, for components in our WordPress application would be services. So we've covered a lot of stuff so far, right? About Kubernetes and about running applications in Kubernetes. But how do we access them, right? How do we access these applications, these networked applications, whether it's an API or a website? Now, at the end of the day, Kubernetes has a really good way of abstracting everything, as you've probably noted so far, right? A lot of different examples. And you can guess as well that networking is also abstracted here. And that is what a service is. A service is this layer of abstraction that exposes some set, and we've covered what sets are, right? It's just a collection of pods as a network service. Now, this service is important because pods come and go, right? They can be deleted anytime, they can be created at any time. So we can't really rely on communicating with them by IP. We can't really rely on connecting to our WordPress site by the IP of our WordPress pod, because that IP may change, right? If we go ahead here, right, all of these pods, they all have, oops, let's put this back here. All of these pods here, they all have, oh, here we go, not again. They all have IPs, right? They all have these 1096 IP addresses. But we can't really rely on them again, right? Because any of these pods can get deleted at any point in time. Maybe the node is restarted, maybe the pod crashes. Either way, the pod is not there, the IP is dropped, and a new one is created with a new pod. So we can't rely on that IP. Services help us route traffic to those because they abstract that away. We don't care about the IP now. We just care about the service that we're going to be routing our traffic to. Internally in the cluster, Kubernetes manages, of course, IPs. There are still IPs, but the cluster is going to manage how that's routed internally. And it does so in a few different ways. It can do so via IP. It can, in most common cases, do so via DNS. And similarly, we can use DNS as well, right, to access our application. Now, how a service works, it's a resource like any other Kubernetes API resource, and it targets pods by a label. So if we get our services, we'll see there's a few different ones here. Let's just take a look at the one for our WordPress installation. And we'll see here what the basis of a service is. There are a lot of different, again, just like all our other resources, they have names, they have namespaces, they have some unique labels, right, to identify them here. But what's important is they also have selectors. A selector is going to let us know, well, what pods does this service apply to? In most cases, it would apply to all the pods in the set. So the selector that you would see here would be applied to the set, which every pod that's created as part of that set would inherit. And this is the same thing here, right? WordPress has a set in the background. It creates these two pods. And these two pods have these labels, which tell Kubernetes, okay, if the service is receiving traffic, well, these are the pods that it needs to go to. Now we also have here a bunch of different info, such as about the IP of the pod, the ports, target ports, and really what we're interested in here is these right here. These two, port and target port, because they help us describe, right, with the service, how we're going to route that traffic. So a port, at the end of the day, it's an arbitrary port. It can really be anything you want it to be, but it's what's going to accept inbound traffic from our node. So our node is going to be expecting inbound traffic on what port? Well, whatever port that we're going to define here under port. Now, because the service sits above, again, it's another abstracted layer. It sits in that networking that networking stack of Kubernetes. it's going to go ahead, it's going to accept that traffic on that port. But now it needs to route it to our application, specifically to the containers within our pod that's running WordPress. So how does it resolve that port to our port that is used in our container? And that's what target port is for. Target port is the actual port that is used by the application. So our container may want us to host maybe WordPress on port like 1234, right? Something weird like that. But on the node, maybe we don't want to expose port 1234, right? Maybe we want to expose port 80. So we'll do that. We'll expose port 80, and then the service, as it receives inbound traffic, is going to map that appropriately to that target port and route that traffic, of course, to our application container within our pod. Now, port and target port in a traditional sense, if you just create a pod and you just specify port, both port and target port are going to be the same. And by pod, I mean service, sorry. If you create a service, both port and target port are going to be the same if you don't specify different ones for each. You can also give them a name, and this is just going to be a unique string to identify this port and target port pair. Because as we create applications, as we create services, we don't want to think about the networking, right? Just like with the storage, we don't want to think about storage. We expect our application to create and run WordPress from a specific folder. It'll do that with persistent values and persistent volume claims. With services here, we want to run our application. We don't care about, well, what port it uses. We just know that maybe it just needs HTTPS. That's what it needs. And we'll give it that name. And that's the unique name that all of our other network components will know this port target port combination by for the service. Now there's a few different service types here, but I see that we are nearing our 9 o'clock, so I'm not gonna get into those anymore. I'm gonna go ahead and call it here. I'll have a lot more of this info again in the same page that I've shared here. I'll share it once again for those that have maybe joined later, have missed it. The same slide deck can be found on this page, so you can read into the rest of these service types along with the rest of these different components that I've talked about here today. The cluster config is also on this site here. So if you want to share or play around with this cluster, the same way that I've done here, you're free to do so. And yeah, I think that is pretty much it. I'm gonna go ahead here and open the floor to questions if anyone's got any.
Yeah, Alvin, I think there was one question in the chat. It says, would you say containers will take over / make VMs obsolete?
Yes and no. That's a good question, Brad. VMs are powerful, right? A VM is a whole set, a whole new file system, right? You can have I could have a VM right now in this Windows machine that's running Linux, right? It's a whole file system emulated on the system I'm running. A container still uses the underlying file system that it runs in, right? It just builds up its own dependencies and runs its own process on the same file system, but in a little isolated environment. So they both have their different use cases. I don't think one will necessarily make the other obsolete. But what I do expect to see in the upcoming future here is we will see a lot of applications that are ran on VMs, on virtual machines, to be ran in containers instead. And that's mostly because it's cheaper. And businesses love when things are cheap. We can have a VM, we can have a virtual machine that's got a lot of CPU and a lot of RAM. But if it's only running a single application, right, then it's not really cool. Right? It's a waste of the rest of the resources. And sure, we can run other applications, right? Maybe we want to run other applications alongside that application, and we can do that. But what do we do when we run into a case where an application requires a lot of system resources or requires something special that the system doesn't have, like a special dependency? Or even worse, what if that application gets compromised, right? And then what happens to everything else that's running on that VM? We can only assume that they're compromised as well. So there is a lot of risks that are faced today with running applications on VMs, and there are a lot of benefits that containers provide that will cause a lot of shift. You will see in both the education industry and corporate and organizations to change how they're architecting and running their applications to make them more cloud native, to run them as containers. There's a whole fleet of reasons. We could talk about them if we have time, or if you're interested, just ping me out. I'll let you know. Well, I hope that answers your question, though.
I think it did, Alvin.
All right, cool.
Awesome. I don't see any other questions in the chat, but again, thank you so much, Alvin, for going through an introduction to containers and also to Kubernetes. If anyone has any questions for Alvin, feel free to message him on Discord. He is a TOHacks team member as well, so he'll be online on Discord and happy to chat with any of you. And as mentioned, he did pop in the resources into the chat. So feel free to take a look at that on your own time. And if you have any questions, again, you can reach out to him about any of it.
Yep.
Awesome.
Yeah, this is some really good stuff for you guys to get into if you are starting your career, because again, cloud native development is where a lot of things are moving into. And it's pretty cool. It's pretty fun stuff, pretty unique, pretty lucrative, and in both terms of corporate use and in terms of if you're getting a job, this is a good place to start making a lot. So yeah, if you have any other questions, again, as Shweta said, reach out to me. I'm in Discord, so just ping me and I'll answer any questions you have about Kubernetes.
Perfect. Thank you, Alvin. And thank you everyone for attending.
Yeah, thanks everyone. Have a good night.
Okay. Perfect, Alvin. You can stop the recording and we will